double check your homework here. So just identifying the graphs. Usually you can spot the key piece that indicates which graph you're dealing with. So it should be B, A, and C for the first three, and then take a look here. A car is moving at a constant speed for several minutes. When it approaches a red light, it slows down and comes to a stop. So not even knowing what that looks like. So let me think here. So cars moving at a constant speed would be like this, and then slowing down to a stop would be this. Okay, so this is speed, and then this is time. Okay, so I'm assuming that's what that graph looked like when you were on your homework.
Could we do running at a constant speed and slowing down?
Yep, that would be fine. Anything, it could be a car, it could be running, bicycle, okay, anything on those lines. So there's definitely more than one right answer. So there you go. So you got graph C, A, and B. All right, we need to finish up a little bit on 4.2 and then get into 4.3. I'm not sure if we'll finish on that, but I'm hoping to get those guided notes from yesterday.
Leave your homework out so I can check it too.
Yeah, leave your homework out. Sure.
I told her not to because then I'll
Yeah, a little quick.
Okay.
You said you did.
Brother.
Yeah.
You can want Hayden to find out anything.
All right, Zach, you're just gonna have to kind of follow along a little bit here. Look off evidence.
Rachel, good. Like
Oh, yes.
Okay. Just a reminder here. Domain and range. We've already done these two. So just kind of, this is on the front side here. But just a quick reminder, if they list them in a table, domain, Preston, you remember how to describe the domain or what comes to mind?
Was it just the X numbers?
The X numbers, the X values. And we put them in order and we don't repeat. So the domain would be 1, 4, and 8. Okay. The range are the Y values, and it would just be 1 and 4. So if they're listed, we just take them, boom, write them down. Domain, range. Now, the things that kind of get a little bit complicated is when you've got a graph. Because you got more than just a single point. We said you have a lot of points. Well, what's the smallest X value for this one? So which is the furthest point on the graph? Okay, Christian? 1. So really all you have to do is take a look. The furthest point on the left is a 1. The furthest point on the right is a 5. Does it hit every other X value in between? Yeah. So that means this is how we write it. It's always less than or equal to, and you put the smallest number first, the largest number last. So it should say 1 is less than or equal to X is less than or equal to 5. So all those numbers between 1 and 5 show up. Well, what numbers show up for the Y's? What's the smallest Y value? Well, that would be the lowest point on the graph. And then the highest point on the graph is that, and everything in between. So the smallest point's a 3. Now make sure you make this a Y. And the highest point's a 4. Now we put the equal to part because it has a solid dot. All right, so we talked about this, domain and range. All right, now be on that same side on the front because we didn't really talk about that bottom piece. We now, very key piece is it's what we call a function. Some equations are, some equations aren't. Here's the rule. Okay, it is going to be a relation, and that means you're going to have ordered pairs. it pairs each domain value with exactly one range value. Okay, so each domain, so if I have 2 in the domain, 2 can only go to one member of the range. So 2 cannot go to different members, then it's not a function. Okay? So if you take a look at those pictures, this is not a function because 2 goes to different things. Okay? It's okay for different numbers to go to the same one. So A can go to 2, B can go to 2, C can go, as long as A doesn't go to 2 things. As long as B doesn't go to 2 things, as long as C doesn't go to 2 things. Okay? So that's the difference. Now these are really simple cases. We got to take a look at some others that aren't quite as simple. All right. Now flip it over. And we talked about this a little bit, but now we got to add parts. So this is the far one on the left. It says give the domain and range of the relation. Tell whether the relation is a function. All right, the domain is the x values in order from smallest to greatest. So looking at the domain, what's in there, Christian?
3, 4, and 5.
3, 4, and 5. Okay, so under domain, put 3, 4, and 5. Under range, it's -2, -1, 0, and 1. So list that under the range. All right, now we're adding an extra question that we didn't talk about yesterday. Is this a function? Look here. Does any x value go to 2 different y values? 3 goes to -2, but what else happens later on? 3 also goes to where? 1. So that means that it is not a function. So just put not a function underneath there. Because you have 3 going to 2 different y values. Okay, 3 going to 2 different y values. All right, so that next one, okay. -4 goes to 2. -8 goes to 2. 4 goes to 1. 5 goes to 1. All right, what's our domain? Okay. As you take a look at those. Jay Lee, what is our domain?
Negative 8, -4, 4, and 5.
-8, -4, 4, and 5. What's our range? All right, Zach, I know you just got here, but you're pretty quick.
2 and 1.
2 and 1. Just put them in order, 1, 1, and 2. So that's your domain. That's your range. Now, does any domain go to 2 different ranges? -4 goes to 2. Does it go to anything else? Nope. -8 goes to 2. It doesn't go to anything else. It's okay they go to the same one. So this is a function. Okay, so this is a function. So make sure you put that down underneath that. That is a function. Now the next one is different because it's not a mapping or a list of points. It is a graph. And we started this one yesterday, I think. I don't know if we got all the way through. This is where your domain, you have to use the less than or equal to. For the x values, what is the furthest point on the left, Christian?
-5.
He says -5. That is this point here. I'm going to go up to the x-axis and mark that. What is the furthest point on the right? It is that point right there. It hits everywhere in between. So it goes from -5 to, what is that, 2? And I think that's what you got down, right? So -5 is less than or equal to x is less than or equal to 2. All right, now your range. Now you have a bunch of points that are the lowest value. Okay, Colin?
Isn't that 3?
Isn't that 3? Yes, it is 3, because why am I thrown off? I am thrown off by that. Let me get that out of the way. Sorry. All right, now the range, what's the lowest value? You got a bunch of them. That whole line is the lowest value, right? And that occurs at -2. What's the highest value? It's all of these points right here, which occurs at 1. So it hits everywhere in between because all those points hit there. So how do I write that? Connor, what do you think?
Confused.
right, look at how the top one is written. It goes from -5 to 3. You take your smallest value to your biggest value, and you always put less than or equal to. What's the smallest y value?
-2.
-2. So you do -2 is less than or equal to. Make sure that's a y is less than or equal to what?
That's 1.
1. Basically, it says that we're trapping it between -2 and 1. It hits everything in between. All right, now we haven't done this yet with this type of problem. Is that a function? Does any member of the domain go to 2 members of the range? Okay, so this is difficult the first time through. It really is. But I'm just curious. What's your gut? Yes or no? Is it a function? Okay. Sam.
No.
No. All right, it's not. Either you got a good guess or you know what you're doing. Now let me show you. Let me do this. This point right here and this point right here. What are their ordered pairs? So, Rachel, what's the ordered pair of that one right there? What's it? We're starting at 0, 0. We go over 1 and then down. Good. 1, -2. What is the point of the one right above it? Grant. What's that?
1, 1.
1, 1. Why does that right there make it not a function?
They both have 1 as x.
Yep, they both have 1 as an x. One goes to 1 and one goes to -2. Now, here's a test that we're going to go over here in a second. We call it the vertical line test. As soon as a vertical line hits the graph twice, it's not a function. So right here, it hits it twice, not a function. And it hits it twice at a lot of times. So anytime that happens, it's not a function. So that is the easy way to tell with a graph. But that is why, because you can say 1, 1 and 1, -2 for that. All right, so we just talked about the vertical line test. Okay. See where you have that line there in the middle? So when graphing a relation, you can tell it's a function. If by drawing any vertical line, if it hits the graph twice, then it is not a function. If it hits it one time only, it is a function. So actually, that's a real easy test to tell. And that's only for graphs. So this one right here, each vertical line will hit it once. That vertical line will hit it twice. Okay? Now, take a look at those two on the bottom. All right, here's my vertical line. Will this hit the graph? Does it hit at 2 points at any point?
No.
No. So is it a function?
Yes.
Yes. All right, now. So it is a function. Oh boy, what's going to be our domain and range? Oh,
Christian, brave soul.
-5.
1, 2. Okay, what does that arrow mean on that graph? You don't know?
Oh wait, it keeps going.
Keeps going. So that arrow is going to cause us some issues. What do you got there, Connor?
Letters, I don't know.
You don't know? All right, this is hard. That arrow keeps going, right? So it keeps traveling this direction. And it keeps traveling this direction. So it will keep going all the way to the left, and it will keep going all the way to the right. Does it have an endpoint on the left or the right? What in the heck does that mean?
Any number.
What's that?
Could be any number.
Could be any number. Any number. And how do we write any number?
How do we write that, or how do we say it mathematically?
Yeah.
X equals the little IR thing.
All real numbers.
Yeah.
All
There you
real
go.
numbers.
Good.
Joe, Christian, very good.
Very good. All real numbers. The range is not all real numbers because it doesn't hit everything. Does it have a highest point? No, it doesn't. Does it have a lowest point? Look again. There is a lowest point.
-4.
Right here. Right here. In the same spot. So it hits at -4, but it hits everything else, right? How do I write that? How do you write that? Or how do you say it? Describe it.
Here, yes, these are obviously the lowest, and you, just by looking at it and glancing at it, you might think that this is the highest point, but you have to remember, it's not ending, okay? It's gonna keep going up and up and up.
Zach?
Would it be -4 is less than or equal to y is less than or equal to IR?
All right, you don't even need that. You're actually going too far. Describe this. Tell me which numbers first. Can you do that? Okay, you can, but I'm not wording it. I'm saying the question back. Christian?
Oh, we write -4, comma, the all the numbers.
I'm just trying to tell you, describe the numbers.
You're on the right track.
You're on the right track. You're actually going too far. Preston?
-4 is less than or equal to x.
-4.
Well, first of all,
Y.
we're not talking about x's here, so we're talking about the range, so it's gotta be y.
Like that?
Yeah.
But why? All right, write it with the y first. So how would I say it with the y first?
Y is greater than or equal to -4.
Yeah, we want all the numbers that are bigger than or equal to -4. So we don't need to put like the all real numbers. And again, and this is a bad case of me. This is not an I and an R. That's my fault.
Looks like it.
I know. It's really a double bar on that R. Okay? So it's not like I and R. It's really just two lines together. And then, so it's really just an R. So that's all real numbers. So this is, you really got to be able to look at these and figure out what's going on. Not easy. Okay, first time through. Okay, you got that little semicircle ellipse? Does it pass the vertical line test?
No.
No, so we say not a function. It still has a domain and range. It still has a domain and range. Does it have a smallest x value?
Mhm.
Yep. Does it have a biggest x value? This is where it's going to be trapped. And it hits everything in between. Smallest x value is, what is that, -4?
Yep.
And the biggest is -4, and it hits everything in between.
Be regular 4.
Regular 4. So -4 is less than or equal to x is less than or equal to +4. Does it have a smallest y value, Allie? What would that one be?
-3.
-3. Does it have a biggest y value?
Yes.
And that is,
+3.
so it's going to be trapped in between there. -3 less than or equal to y is less than or equal to 3. Make sure you put a y there. Make sure you put a y there. Okay. All right, so that's kind of the end of 4.2, dealing with.
That was confusing.
That's confusing.
Let me just start from right here.
Vertical line test.
Windows, we always use less than.
I got. All right, now as we move into 4.3, make sure you keeping these notes handy. Identify independent and dependent variables, and we're going to talk about functions and what's called function notation for this. All right, determine a relationship between, is this the first thing you got down? Okay, determine a relationship between the x and y values. Basically, give me an equation. So would y equal 2x be the equation that matches that graph? Let's talk about that, yes or no? And how do you tell? Josh, yes or no, and then how do we tell? Not sure? Okay, well, this says take X, and when you plug it in, I get back a 1. When I plug in X into this, what do I get back?
Oh,
If I plug in 5 into that, what do I get back?
10.
10. So this would be the point 1, 5, 10. So that doesn't work. So when I plug in the point 5, I get back 1. When I plug in 10, I get back 2. What do you got?
You gotta divide by 5.
He says divide by 5. So you take y equals, y equals x divided by 5. All right, does that work?
Mhm.
It's 5 divided by 5, 1. 10 divided by 5, 2.
Mhm.
15 divided by 5 is 3. Okay, so that is your equation. Write that down. Y equals x divided by 5. Again, this time you have ordered pairs. If it helps you, you can make a table. You may or may not need to. Okay, but 1 goes to 3, 2 goes to 6, 3 goes to 9, 4 goes to 12. What equation would give us that, Christian?
Y equals, I don't know, 3 something, 3x. I don't know.
Well, you raised your hand, not me.
Well,
Stop
like,
forcing them to
it's
answer
times,
questions. Do that.
it's multiplying by 3.
All right, well, does that work? That's what you do. Look at it. Does it work? Sam says, yeah. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9, and 3 times 4 is 12. So yeah, that's all you got to do. All right, now this next one, a little bit harder. So I want you to think about it. Try some things. Write down the equation. Try it. Doesn't work? Think about something else. So see what you can come up with. When I plug in 2, I got to get back 9. When I plug in 3, I got to get back 11. When I plug in 4, I got to get back 13. What'd you say, Joe? 18. No. 2 divided by 18 is 190. 2
First one was right.
Oh, we're trying to find the relationship.
We got to figure it out.
Yeah.
It could be different each time.
2 cheated on 9. Huh?
I said 4.5.
What about
The first one was right. And I checked the second one was wrong.
So that means
Yeah,
this is
4.5
not the
was
right
the first
equation.
one was right.
6, 17.
This is 13.
All right, so now here's what some of you are figuring out is like it has to work for all of them, not just one of them. Okay, so you said, all right, y equals 4.5x. Because what is 4.5 times 2?
9.
9. But what's 4.5 times 3?
13.5.
13.5. So it's not 11, so it can't be that. Okay, it can't be that. All right, anybody else have any other suggestions? Okay. Preston? Oh, there's an answer. Connor?
What if the x or y equals x times 4.5 or 4.5x?
Well, that's what we just did, didn't we?
Yeah.
It's wrong.
Well,
It works for the first one, but 4.5 times 3 is 13.5, and for that to work, it has to be 11. So when I plug in 3, I get back 11. Okay. Allie, any ideas? All right, so this is a little bit harder. What's that?
You have to subtract by something, right?
Maybe.
That's what I'm trying to find out.
All right, take a look at the y values. Is there a pattern? They're going up by what?
2s.
2s. Right? 9 to 11. I'm going to give you a clue. This is part of the answer, but it's not the whole answer.
I got it.
Grant says he has it.
Is it, hold on, wait, that's just it. The first one, it's 2 times 2 plus 5.
And then what?
All of them. And then 3 times 2 plus 5.
And then,
4 times 2 plus
so what would the equation be?
y equals 2 times 2 times x plus 5.
Like that?
Yeah.
All right, now here's the question. Does it work?
Yeah.
What you got? Does it work for all of them?
Yep.
Okay. 2 times 2, 4, plus 5 is 9. 2 times 3 is 6, plus 5 is 11. 2 times 4 is 8, plus 5 is 13. So, and then you get 15. Yes, that's it. It works for all of them. All right, now how did he do it? Now here's a little bit of a hint.
Experiment.
Yeah, sometimes you just try things. You're right. Sometimes you just try. But look at the Y's, and here's a hint. They go up by how much? 2. That means that there's a 2x in our answer, okay? Since they're going up by 2. Now, you got to figure out, it's not just y equals 2x, because that doesn't give you the 9. Then you have to add or subtract something off of that. So obviously you don't just multiply by 2, but you have to take away or add something. So you take a look at the pattern. The first 2, you could figure those out because it was either a straight division or a straight multiplication. But when we add or subtract, it's a little bit harder. So look at that third one, or D. Take a look at it. It's, again, not an obvious one, but look at your y values. What do they increase by each time? So what does that indicate is in the equation? Okay, Preston?
3x minus 2.
3x minus 2. Does it work for all of them? If it works for all of them, that's got to be the answer. Okay? And right now, you're not going to come across 2 different answers. I mean, I'm trying to think if there's a case where that comes up. I can't think of it off the top of my head, but it's going to be a unique case because it has to work for every single one of them. Okay? So that's a little bit harder. That's definitely a little bit harder for that. So now we've talked about this before. We're going to continue. The input, like what you plug in. That's what we call the independent variable. The output, which is our y, okay, is the dependent variable because it depends on what you plug in. The value of the dependent variable depends on or is a function of the independent. Now, a couple of key things here. This isn't on your sheet, I don't think. Okay, just pay attention to this to kind of give you an intro. In the winter, more electricity is used when the temperature goes down and less is used when the temperature rises. So what would be the independent and dependent variable? Which one depends upon the other one? So think about that. The amount of electricity used depends upon the temperature. So which one's independent? Temperature is independent. Okay, Colin, turn around. Dependent is the amount of energy. Okay, so which one depends upon the other? So think about this one. The cost of shipping a package is based upon its weight. All right, you have weight and you have cost. Which one depends upon the other? Cost depends on
The weight.
weight. The more the weight is, the higher the cost. Okay, so the cost of shipping depends on its weight. So the dependent is cost, independent is weight. The faster Ron walks, the quicker he gets home. And sometimes it's inferred within a province. They don't just come out and say it. So how long it takes him to get home, which is time, and how fast he walks. So think about this. The time it takes depends upon the speed. Dependent is time. Independent is speed. So if he picks up his pace, he's going to go quicker. All right, so now this is the one on your paper, right? Okay. A painter must measure a room before deciding how much paint to buy. What would be independent and dependent? Christian?
The size of the room.
Okay, size of the room would be which one?
Independent.
And then what would be the dependent?
The amount of paint.
Okay, so dependent is amount of paint. Measurement or size of the room would be independent. Okay, so clearly, how much paint you want to buy is going to depend upon how big the room is. Identify the independent and dependent variable. Okay, company charges $10 per hour to rent a jackhammer. Okay, so here's what I'm gonna tell you. Total cost is 1. Okay, what do you got, Zachary?
Independent is how much you pay.
I'm gonna disagree.
How many hours is?
Okay, yep, number of hours rented.
Time rented. Can we put time rented?
Time rented is fine. And then cost, or sometimes you want to put total cost based upon whether there's like an upfront charge. Because the cost is going to depend on how many hours you rent. Okay, for that. All right, now you got that little table down there. And this is different ways we refer to independent variables and different ways we refer to dependent variables. Independent are your X values, okay, what we plug in. Your domain, your input, and then X. Y values are your dependent. Range and the output. All right, what is that little symbol there in the bottom right? Have you seen that before? I don't know if you have or not. Sam, does that look familiar at all? Kind of? Does anybody know how we read it?
Sometimes X.
No, we don't even need to say that. Really, you just say, this is what you say. You say f of x. And you're right, it's a function of x, but we don't even say the word function. So I can just say f of x. Okay, that's how you would read that. Now, here's where we're heading. Y equals 2x plus 5. If this is a function, we can say f of x equals 2x plus 5. It serves a similar role as y. We plug in x values, we get back f of x values, okay?
So would it still count if we put y equals?
Not if I ask for a function, okay? So it depends upon the wording. So an algebraic expression that defines a function is called a function rule. So that's basically what we talked about. Now, let's see where you at. It's at the bottom. Okay. So there's your function rules for that. Now, so f of x, if we say f of x, you have to say like 2x plus 5. Now, it's not exclusive to the letter f, and it's not exclusive to the letter x. So if I said f of m, that might be 3m minus 2. So that says I'm using the variable m, and then it has to be an m in the equation. Also, it not always is just the f of x. That would just be g of x equals, I don't know, negative 5x plus 2. Or g of m equals 2m minus 1. Okay? It's just saying we got a function. And I can plug in either values for x or I can plug in values for m. M is your independent variable, f of m is your dependent. X is your independent, f of x is your dependent.
What's g?
What's that?
What's g stand for?
G, well, we just use different letters. It's still a function, but since sometimes we're talking about more than one function, I don't want to use the same letter. I got to use like f of x is one and g of x is another. Okay, for that. All right, on the back, we're just going to do this last one here, and we'll finish the rest tomorrow. There should be one at the top there. Identify the independent and dependent variables. Write a rule and function notation. I'll show you what that means.
You spelled dependent.
Where?
Oh,
Oh, how do I spell it?
Dependent.
Oh. Okay. So now, a fitness center charges $100 initiation fee plus $40 per month. So we got the dependent variable and the independent variable. All right, what do you think? What do you think? Connor?
The independent is, the number of, number per month, amount per month.
Say that again?
The independent is the amount per month.
Not the amount per month. Not the amount per month. Joe?
The number of them.
Number of months. So it's whether it's like 2 months or 4 months or 6 months. So it is the number of months. Dependent is going to be the total cost. So you gotta watch, don't put in the numbers there. Now, it says write a rule in function notation. So normally you would say y equals, if it says function notation, we gotta use that f of x notation or f of m. Well, let's just think what the cost would be. Let's use y first because you're more familiar with it. And let's use m for the number of months. So what would be the rule for the cost? How would we figure out the cost? Where does the $100 come into play and where does the $40 per month come into play? What do you got, Colin?
So it could be 40x plus 100.
I'm gonna use m.
40m plus 100.
So it'd be 40m plus 100. All right, so that's an equation, but now if I'm gonna write it in function notation, instead of y, what do I have to put in that spot? I gotta put in f, and if I have an m here, f of m equals 40m plus 100. Or if you use the letter x, you could say f of x equals 40x plus 100. So at this point, the reason I use that is because it says use that function notation. Make sure this letter matches up. If I have an m here, there's an m here. If I have an x, I have an x. Okay? All right. Let's see. Good. I feel like we're back on track. Not a lot. They're just these are not a lot of homework problems.